Hello, my hosts, and welcome to another... actually, this is not going to be another. This is my first doing math exercises stream, where I am going to be doing the maths exercises out of An Introduction to Formal Languages and Automata by Peter Linz. Just give me a second. I'm just going to add a capture for my Google Doc. And there we are. Let's just adjust that size slightly so we can see what's going on in there. It's a little bit, hopefully that's sort of readable. Let's go like that. Oh, that's not what I wanted. I wanted to do that to make it full screen. I think there's a button to hide. There. And we'll go zoom 200%, so it's a little bit more readable. Right. All right. Just move you there. Looking good. Oh, it says sus on the math exercise. Ah. Yes, it does. All right, let's go to the first one and see if we can do it. Oh yeah, the union symbol. S union S. Okay. We're all set up. So, exercise 1 is use induction to show that if S is a finite set, then the cardinality of 2 to the power of S, so the power set of S, is equal to the cardinality of equal to 2 raised to the power of the cardinality of S. So if we're going to go an induction proof, we've got 3 parts of that. So first part, oops, base case. So we're going to be proving to raise S. So going to prove it for the empty set. So slash D. I'm just going to write this in. Hold on. Do we have an equation editor? And do I want to use it? Tools. Notification, accessibility, preferences, formatting, insert equation. That's going to be a... Okay. 2, does it... Oh yeah, it does do that. Excellent. Equals 2... I said 2. Bang. Yes, okay. Right, so we'll move you up there. So this is what we're trying to prove. Let's... First things first, we're going to prove the base case. So that's 2 to the power. Can we get an empty set? What? We normally have a notation for an empty set, but today we don't. I'm just going to say it's going to be a 0. Oops. Of 0 equals to the power, bang 0. This is true because it's equivalent to 1 equals 1, because the power set of the empty set has a cardinality of 1, and the 2 to the power of 0 equals 1. In case, sorry, inductive step, assume that's the case, new equation, so 2 to the power of S equals 2 to the power. Oh, I don't keep on typoing it that way. Two to the power of S, where equals N. Now, using that fact, we have to prove that to the S plus 1 is that case. So we have 2 to the power of hit the new equation button. 2 to the power of S And just the small union. Some random element, so that's not in S. A, B, C, D, E, F, G, H, I, J, K, S. I'm going to say T. Sut. Okay. That equals two to the S union right, so it equals all the elements that are previously in there and then union, I'm just going to put a circle here. How to explain this? Gonna say image. Can I? Is there a big I? There isn't really. What I was to say is actually for each, so I'm just going to be using this in an unorthodox manner to mean for each. So we'll call that I arrow function here we get arrows. There's no the features in here are lacking. They're not good at so hold on. Okay, I union so the set of I so basically this set plus the other set and I let's see, is an element of. Actually, we could use A, but well, it's uh-huh. I just want the small union. There we are. But I don't want that. I want the is an element of. This is really lacking symbols. I should have tried this out before. Oh, there that. I is an element of S. I'll add some notes. Oh, no. Put that off. Where T is not an element of S. Then we go down one thing. That equals, since this applies the same an operation to every element in S, it adds that on, so we can go bang 2 to the power of S plus that thing. And there we go. To the power of S. Hold on, that's wrong. Hold on. No, it's not. We know that's already the same size as 2 to the power of S. Because that's actually 2 S rather than each element of S. That's what I missed. Right. So 2 times 2. Oh, gotta go into new equation mode again. All right. I'd only do one exercise from this at this rate. 2. S. Yeah. 2 to the power of s equals, yeah, almost there. Our new equation equals 2 times 2 to the power of s equals 2 power of s plus 1. QED, because we were meant to show that n being Pn implies Pn plus 1. So that is a satisfactory proof. Somewhat paradoxically, I've relied on the thing that comes in the exercise 2 is S1 and S2 are finite. Prove the cardinality of S1 union S2 equals, oh, actually less than or equal to n plus m and to pi king. All right. Let's say make a simplifying assumption. 1 union S two, actually not union, intersection equals, could just, nope, equals 0. assuming that 0 is the empty set. So by the definition of numbers, there exists a bijection equation S1 all right. What symbol are we going to use for the bijection? I've just got to call it F S1 N which goes from S to the set 0 through n minus 1 bijections, that one. And to M that's just simply from the definition of numerical equality. There we go. Oh. Then we can construct a function f bracket here. It's 1 union S 2 n plus m which is of type which equals Where is big K? Is this a case statement layout? Doesn't look like it. It might be. Hold on. Let's try it. Okay, that equals... what's it? F S 1 N make it clear with not an N, an M. We'll have I for in. We'll call this P. P is less than N. This is a dreadful thing. If I do this again, I'm going to use latex. And then I can't remove that. And we copy that. To M minus and P is greater than or equal to . Now, this is a from this is an injection from that term. Can we just copy that in more into all right. Have to add it as a new equation. 0 dash n plus m minus 1 and it is div as well, so it is a binary function, hence copy that. That equals that. Where that's that case. In the case where there is a element, then the function is div, so it must be greater than or equal to. There, that's fine. How long have we done this? We've done this for about half an hour. Let's continue. On to question 3. So, I'm pretty sure this wasn't the technique I was supposed to use to solve this one, but anyway. All right, new equation. S1 and S2 are finite. S1, the cardinality of S1 equals n cardinality of S2 equals m, and we want to show that it's 1. Do we have a cross symbol here? Cross S2 equals mn. I think we can do this with a case of double double induction. So lemma is so we're going to prove. So here's the sketch I'm going to do. Prove it for P0n, then prove it for prove it for P00, then P0 N. Then P. Actually, would be better to go N 0. Then N M. So basically, our inductive step is actually a base step for a further induction. So base case n equal n equals 0, m equals 0, copy this. So that is empty set cross the empty set equals 0. Right. So what div step is that P 0 N M goes to, assuming Pn goes to that, Pn plus 1. All right. I am actually mentally exhausted. So after we finish this one, I'll probably go on there. Right. So go into the inner base step. We've already done. So dep P 0 M to P N plus 1 M okay, I think I am going to call it a day here because my brain is just a little bit overheating. But basically what we'd do is we'd prove the induction acrosswise and then downwise. Although expressing how I'd express that cleanly is a little bit beyond me at the moment. Thank you everybody for watching. And I hope to see everybody soon. I hope I haven't scared anybody off. Anyway, I'll see everybody tomorrow. What are we going to be doing tomorrow? Let's just check my schedule. It's probably something far more traditional. All right. some Factorio. Excellent. Hope to see everybody there. Thank you very much, and I hope to see you later.